Actually, I came here from Krakow, and today morning, very morning, when I get to the train, it was raining like hell, and here it's very sunny, so yeah, I like the city. So in Krakow, I was actually a software engineer, systems engineer, network engineer, security engineer, etc., etc. That basically means that I worked on everything, and one could say that I suck at everything, but I know things. So today I wanted to tell you a story of no ops company that stays for no operations. We actually, 100% of our engineers are developers, but me, so it's actually 99% point something. And before that, I would like to ask you, how do you guys, all of you, I mean some of you, learn the reliability? I mean, give me some ideas. How do you learn about reliability? Yeah, I love you for this, the hard way. I was actually prepared for this, because, yeah, I studied physics many years ago, and that's why I picked this guy, and he told this very famous sentence that you can learn, you can become expert in some area when you commit all the possible mistakes in that area. I can agree with that. However, learning the hardware is not always an option. A couple of weeks ago, a friend from my team, he took us to this glider. He's a pilot. He's a pro pilot, and also he works in our company in whatever. But as you can think, learning the hard way, being a pilot, is not the best thing you could do. Yeah. So how they learn about the reliability, or rather security, etc. I asked him multiple questions when I got inside of the cabin, and the first thing during takeoff, before takeoff, he actually told me, Maciek, don't talk to me when we are taking off, where we are on behind the supporting plane that is taking out to the elevation, and when we are landing, and also when something happens. Don't talk to me at all, because I have to be 100% concentrated. Okay, cool stuff. However, they also have this thing that every year they have to pass technical exams, even though he flies like 2-3 hours per day, or maybe per 2 days, so he consistently fly and pilot. However, he has to repeat these tests all the time. And we in IT, do we do that? I mean, as far as I remember from my experience, sometimes it's like something happens, something doesn't work, and we, instead of solving the issue, we are reading manuals and learning the tools that help us solve this issue. So we are not that prepared, yeah, and they are, yeah, so we could learn from them. Okay, however, these days, thanks to virtualization, containerization, Kubernetes, Podman, Docker, etc., we can create virtual environments in which we can simple practice. So this is one of those. Actually, this is the practice for aviators. Experience is built with time. Actually, this is what I wanted to remember from this slide. You can learn experience. You can learn the hard way. The hard way means it's built with time. However, you can also read and learn about experience and mistakes of others. Who of you knows this book? Even one person? I mean, wow. This book has like 10 years old. I mean, is like 10 years old, and it was written by John Allspaw. I mean, he was a co-author. And John Allspaw is the person who stays behind the whole DevOps movement back in 2009. So 10 years ago, when in this book, there were put all the things you actually needed to put your application to the cloud, to learn about that database reliability, about the general approach to keeping your applications reliable, and about thinking how customers sees and feels your services. So actually, it's there. And this book is like this tiny. So it's 1 weekend reading. I'm going to publish those slides afterwards. I mean, those are actually already published somewhere, so you can see which exactly the book is that. And what's inside? And also about agile infrastructure, so whatever that means, because I can't really think what is an agile infrastructure. Okay, basically it's a must read. Why also I'm talking about this book? Because I personally think that extraordinary engineers are not developers or system administrators, but someone who does this thing and that thing. Being an expert engineer means that you know everything about your application, and everything means how it works, and how it, how it works for the customers, and exactly how it works on the target environment. Then you can call yourself an expert. So that's why this book should be read also by developers and operations. Okay, coming back to CodeWise, probably I didn't use that name before. This is company I'm working for. So like 3 years ago, they asked me to join them, and they tried to sell themselves with some tempting numbers. Okay, so those numbers were like Maciej, 400 Ks requests per second. Okay, cool. Didn't have that scale before. And like 1 to 2,000 virtual machines, like big one virtual machines. Okay, I had like 500 before, so maybe, and 1 petabyte of egress data. Basically, it was very interesting from my point of view, because to that numbers, I could add the information that there are no system administrators there, and they handle it somehow for the last 5 years or something. So I thought that I'm gonna get in and just start this Wonderland journey. So first day, and CTO of that company told me, Maciej, okay, so now when you are here, just find yourself a job. I'll go around the guys, and we're gonna talk in like 1 or 2 weeks or something. Okay, cool. And first thing I learned that they were really no ops company. I mean, no system administrators, no special teams for on-calls or whatever. And also, what do developers do when they want to use a huge database? They don't use RDS or whatever. They write their own database. So they created own database for some solutions. Also, they created their own monitoring solutions. I mean, everywhere I turned, I saw services they wrote. It's an anti-pattern, you know, and it wasn't. I mean, I kept silent because I had to get some buy-in and not criticize at the very beginning, but it was quite a discovery for me. I started with searching for operational threats, meaning what kind of services we have, we host, we maintain, that we don't know anything about, or we don't know how to get from the failure in like 5 minutes or 10 minutes or whatever. And there was this Cassandra cluster, actually. So we had those, and those clusters were the core services on top of which our applications were working, and the restoration part and some others were not, were far from ideal, let's say. Okay, so the more I understood, the more WTF I was. I mean, it's me exactly after 1 week at this company. What? Okay, how does this even work was the question I was keeping asking myself and everyone around. But actually, I liked one thing, which maybe on this conference is not the best thing to say, but them, used only auto-scaling groups, simple EC2s, and Java applications on top of that, because this is Java house. And the performance tuning was done exactly for specific instance type, and that was all. And that's why it was working flawlessly, because there were non-complicated parts. If we wanted to scale horizontally or vertically, we just used auto-scaling groups or something else, and we just created higher, we just used the bigger machines or whatever. 100% in the cloud, and cloud means AWS services and Google Cloud. And they learned the reliability the hard way, especially thanks to S3 failures, etc., or whole region failures. Yeah. So I realized then that this company is 100% DevOps company. not having any operations teams. And what does it mean, DevOps company for me? They talk to each other, which was kind of a nice thing, and they had this culture of trusting each other, which is a very important thing in every company. I mean, if you go to some team and ask some guy to do something, and he tells you, okay, I'm gonna get it in like 1 week, then you just trust him, he's gonna do it. And it was cool, because in my previous companies, not telling any names, it wasn't like this every time. It was harder. They listen and learn on mistakes, and this is a very important thing in DevOps, let's say, company. Learning from mistakes and also working on some data. I mean, if I want to do something, then I just collect some data about that, and then based on this data, I do something. Okay. Today I heard that someone here is a DevOps engineer. How many DevOps engineers here in this room? Okay, there are some. And how many DevOps engineers in your companies where you work? Do your company have DevOps engineer? Hands up. Okay, that's like 30%. Okay, please stand up, everyone. Stand up, guys. Stand up, stand up. There's going to be a little practice here. Okay, and now repeat after me. I will not call anyone a DevOps engineer ever again. Okay, you may sit down, thank you. Guys, you can't hire, buy, or whatever else DevOps. It's just, you just can't. If you are doing this, you are conforming to some DevOps anti-patterns. So maybe there is a little chance that it's for some reason, for some specific reason, for like 3 months or 4 months. But there has to be a reason. DevOps anti-patterns are on DuckDuckGo, or Google, or whatever, and you can read about that. So please don't do that. Okay, back to SRE. When I got there, and after everything I told you already, I started thinking, okay, how to approach this reliability thing in this company, in this specific company. First of all, I read those 2 books. The left one is a theoretical, and the right one is a practical. Even though I studied physics, I had problems with the left one because it's like so over-engineered and it's so a huge book. Oh, it took me time, and I read it, understood it, etc., etc. So now then I took shortcut, like a $50 shortcut, and I took this course. It's like 3-4 hours per week, 4 weeks or something, by Googlers. And it was cool. I would highly recommend this one to every developer that works on the backend and frontend and whatever. Simply for every developer. Operations guy should at least try to read one of those, especially the right one. Okay, that's about theory. And one more, Charity Majors. She is behind the Honeycomb company, which is some monitoring / whatever company right now. But beforehand, she wrote this book, and she's an expert in the terms of databases reliability, etc., etc. So even though after reading this book, I could write one more chapter or something, but also highly recommend this one. Okay, so now let's get back to SRE. So what this SRE is all about? Site reliability engineering. It's basically about answering, how do your customers feel your services? If they feel it right, if it works for them, then there is no problem. And if it doesn't work, then we might have a problem with reliability. And also how much reliability-related work is needed, because reliability-related work is like endless well. I mean, you can work on operations part of your services for time, I mean, for days and months, etc., and never finish. So the question is when to finish, actually. So Googlers have SRE teams. Facebooks have production engineering teams, and etc., those big companies. In that world, it works like the SRE teams have on-calls. or production engineering teams have on-calls. So basically, if something happens, they get the call and they respond somehow. So before service is put on production, it has to conform with some reliability checklist provided by the reliability engineers, and developers have to conform to this checklist and fill out all the gaps. And it's cool. However, however, in CodeWise we don't have SREs, we have only engineers, so they are actually our SREs. Another thing, CRE principles. CRE stands for Customer Reliability Engineering, and it's the part of SRE, of reliability engineering, that takes care of how our customers see our product and how they feel this product. The first thing is to understand that reliability is the most important feature of your product, because if something doesn't work, if it doesn't work for your customers, then it doesn't matter how many features it has, how many cool features, it just doesn't work, they won't use it. Another thing is that if someone tells you that it's not working and your monitoring tells it's working, then actually they are right. I mean, it's not working for them for some reason, and it's your job to find out the reason why. Maybe because your monitoring is working on Europe, not on South America, and for some reason they just can't reach your services, etc. So it's about that. And also, so this is a theory. Basically, if you are a super software engineer, and you create just extraordinary application, then putting this on one virtual machine gives you like this amount of unavailability per month, like 40 minutes. Why? Because your VM will get down, your network connectivity, or rather your customers will be down, etc., etc. So having well-engineered applications gives you this number of unavailability per month. However, if you have operations teams, or if you automate and use cloud or whatever, then you can get to this number, and it's quite a cool number. 9 minutes of a downtime per month is acceptable for probably most of the businesses. And then there is this last number, which is hard to achieve. Why? Because in order to get these 5 nines, you have to you have to work on automation, on monitoring, on self-healing, and there are many other things you have to work on. And it requires a lot of money and a lot of work from everyone in engineering and also in business. And not every company can afford this number. And also not every company needs this number, because if you are working in some online shop which is shut down out of working hours, I saw that one, then maybe you just don't need. Okay, and everything else is error budget. And about error budget, I'm gonna tell you in a couple of minutes. Okay, SLAs. Basically, SLA is an agreement between you as your company and your customers, and you agree on downtime for some time. So basically, if you are a SaaS company and you are providing, let's say, monitoring solutions, then you tell your customers, okay, so we might be like 5 minutes downtime per month. Is that okay for you? And they can tell yes or no. In monitoring solutions, probably no, but in some other solutions, they can tell yes, and everything above those 5 minutes will require probably some fees, or there will be consequences. So this is SLA. SLO, it's basically some characteristic which helps you to conform with that SLA. So basically, if you tell that you agree on 5 minutes of downtime per month, then you have to somehow measure it. So you measure page availability, and that's the SLO, page availability, and you can tell that target SLO is like 4 minutes for a month, because SLA is 5 minutes, so let's stick to 4 minutes. And SLI are metrics, those low-level metrics that helps you measuring those SLOs. Okay, and about error budget. You set error budget basing on SLA and SLO, just as I told you. If you have 5 minutes of downtime on which you agree with your customer in SLA, then let's say that you target your SLO for like 2.5 minutes, okay? And up to these 2.5 minutes, you can just work with, I mean, you can live with that. 2.5 minutes is okay, and that's your error budget, during which you can do everything. I mean, you can plan to, you can tell that all hands on deck and we are working on this, but actually you can also tell that we don't care because error budget might be also like 60 minutes and it's fine. And we know that this particular service is actually and usually down for 30 minutes per month, and that's cool. No one cares. And thanks to that, you don't lose your time on working on improving it because someone told from business that 60 minutes per month is okay, so we don't care. And visualizing error budgets, it's like, yeah, it's like this. Also, error budget and SLAs, SLOs, etc. can be and should be actually split and different for each service. So some example table which shows you how it might work. And yeah, the thing that when I met with the business guys, they told me, actually there was this one guy, and he told me, Maciej, it's cool, but I would like to see this reliability thing somehow. So, I mean, this is not our dashboard, but something like this you can prepare and you can make them see the reliability thing in some charts, and it's cool. Okay, and toil. The last thing of this reliability theory, I think. Toil is all this repetitive work that is from one side or manual or not really needed. I mean, it shouldn't be there. It should be automated, but it's not. For instance, when you have to restart your Java applications every night. Is it needed? Yes. Is it the repetitive? Yes. Can it be automated? Yes. So why not? Because it's a waste. Also, if you are doing something like you log in and you restart this application, and you know that you're going to have to restart it in one day, it's a waste. So why not automate it right now or somehow plan work on this automation? It should be there. Okay, after toil, setting up the reliability. I mean, this is me after reading those books, talking to people, understanding how we work and how to work on this. I mean, developers, they don't like to be told that they suck at operational things. So I didn't tell him that, but I thought about that, exactly about that. And yeah, from one part, we are not Google size, so these whole books, these big books, were not applicable to our environment. We won't have SRE teams, that's for sure, and we always customize. So basically, I thought that we are in this DevOps culture. Let's start with talking. Okay, so I get one very super expert engineer from every service, from every team. I gather them and I ask them to meet and to talk about reliability. So I created this and called this SRE group. And the thing is that when I was choosing these people, I chose those one with this reliability mindset. I already know them, and I knew which one of them is able to talk and to discuss backend related things, infrastructure related things. Because probably, as you know, not every developer knows in details how it's working beneath. So just choose those one who knows. Okay. We had this DevOps culture, as I told you, but we didn't have reliability culture, meaning we discussed with each other some problems, etc., but we didn't discuss the reliability-related problems across teams, and that was the problem. So we created these meetings, and I just asked guys to put on paper any idea that goes to their mind when I ask them about reliability. So they put those ideas like this one. Then I grouped those, and we voted which for them is most important. And for some reason, the most important one was self-healing. And why is that? Probably because they are on call, so they don't want to be woken up during night. So let's make self-healing. Okay. So then we started regularly meeting every 1 week for the beginning, then every 2 weeks, then we had some break because of things, etc., etc. This break is here, reactivation, as you might see. Okay, so what does it, where we got? First 3 meetings were actually discussing about organizing these meetings, what do we expect from these meetings, and what do we expect to work on, and how our business would work on this. Then, yeah, we had 3 meetings about self-healing, and this is where interesting things start, meaning we started discussing one by one how they work on self-healing on those services. So these guys have auto-scaling groups, and they think this is self-healing and that's enough. Those one told us that they have this guy and he's working on self-healing, meaning manual self-healing, etc. And some other team came out with some cool solutions because they have monitoring, and for this monitoring they have connected some scripts that are run when something stops working, and those scripts are recreating the environment. And this is quite a cool self-healing, however it is done. Okay, so one of the most important things is that from this, moderator is needed for those meetings. That's why we had this reactivation stuff here. Meaning, when I was not in the company for like 2 or 3 or 4 weeks because I broke my leg or something, then those meetings were not there, so it wasn't cool. So moderator. Or 2 moderators, and yeah, that. Okay, isn't it too loud now? Okay, okay. Postmortems. Yeah, this company doesn't have the culture of postmortems at all. Postmortems are meetings that you run after some outage, and you want to know why this outage was there, what we did properly, what we didn't do properly, and how to work so this doesn't happen again. So for me, postmortems are not always needed, and we don't do them at majority of events. We do postmortems always when business was impacted. That's the most important thing. Everything else is just written down as a note, and then we talk about this at those SRE meetings. For instance, this weekend we had some problems, but business was not impacted, so in train I just asked guys to take a note, and we're going to discuss it this Friday. Okay, blameless postmortems, this means. Basically, you don't want to pick on a guy and tell loudly, "Oh, it's your fault." You don't do that ever. I mean, it's not even important. What's important is how this happened, why this happened. Another example, what we did on these meetings, we created service catalog. This is just a tiny part of our services from infrastructure. And we simply created columns, and all those columns were discussed during consecutive meetings. For instance, what is the severity of this service? And free for Cassandra it's the most important thing. How it's provisioned, where is the documentation for the provisioner, how is it monitored? You can see clusterfuck of monitoring, Sentinel, Datadog, and Tornado for just one service. Why? And is there a self-healing? Yes, no, partial. I mean, actually now it's yes, it's on old slide, but here is no. Some comment. Failure scenarios. Did we think about failure scenarios? Did we test failure scenarios? And did we document these failure scenarios? And where for that? And some other stuff that we are adding columns with each other meeting. And it's common work of every team, so it's a really cool thing to have. It builds awareness. And basically, if one of the teams have no, let's say here, then they can think between each other, why we have no, what to do to have yes, and then they just read how others do that, works on that. They talk to each other. Hey guys, how do you self-heal your services? Oh, we do this and do that. Oh, cool stuff. And sometimes we run workshops, meaning they invite me to a meeting. And I sit there and listen how they discuss the reliability-related stuff, and I'm just there to help them. Yeah. About business, as I told you, the business is one of the most important. The business buy-in is one of the most important things, because if business doesn't understand that reliability is the most important feature, then you won't work on this because you won't have time. You won't have time in your iterations, etc. So you can copy paste this. It's basically invitation for a presentation I run across our company, where I invite all the major business-related people and just describe them what's reliability engineering, how it can impact us, how they will, what they will get from it, etc., etc. And they were there and they bought it. How to convince them when you talk to them one by one? Copy paste or go from top to bottom. That's all. And another thing that you need to understand, actually I needed to understand, was that every group of people have different understands reliability in different way. For developer, it's something different than for business people and then for manager. So in order to learn that, I'm still conducting meetings with all those three parts, all those three groups separately. And I talk to them about reliability, how they think the application is reliable, what do they want it to be reliable, and that's all. And then when I have the bigger picture, we can run some workshops on or discuss it further. User journeys. You define, it's one of the important things for your services. Define user journey. So basically how your users use your services. And to create user journeys, you have to talk to business guys, because they are the best people they know how your services work. If you are the developer, you probably know. Systems administrator, he will not know. He will probably know, but business guys always. So having defined user journeys gives you possibility to define SLAs, SLOs, etc., etc. And what might be an user journey? Let's say you have online grocery or something. So user journey would be get on the index page. So the first SLI, the first metric would be what's the time for rendering the main page. That's cool. Okay, then you enter the search query, hit enter. So you might even start measuring how long it takes to enter the search query, if you have some auto filling or something, or not. And then you just present the results. So the other thing would be how long it takes to present the results to the user. So we've got like 3 SLOs, and then user hits the page, some particular result. So how long does it take to actually present those results? 4 SLIs, 4 SLOs or something. And that's all. 3 up to 5 SLIs per user journey. It's max. Why? Because you don't want to complicate things. You don't want to get like 100 notifications when something went down. You want to have just 1 or 2 telling you that index page is not working, because it's enough. The information is index page is not working. Business understands it, developers understand it the same way as business, and system administrators also. And another thing, consistency is the key. As I told you a couple of slides before, we had this break in our meetings because I was not there. What it means, I took part in this sport event. It was like I was preparing for it for 4 years. You start in Norway, where at 4 a.m. you jump from the ferry to the 12-degree water in the fjord. Then you swim like 4 kilometers. Then you have 200 kilometers bike leg through Norwegian mountains. It's like 5, 6, 7 degrees. It's very cold. And then you have this marathon 42 kilometers run up to this mountain, Gaustatoppen. It's the highest mountain in the Telemark. How do you get there? You keep training for 4 years. So consistency is the key, and I know something about that. Repeat and update, repeat and update. Keep those meetings running all the time. Keep talking to people. If you see that some team is not participating in this meeting, go to them, ask them why, how you can help, etc., etc. Yeah. Observability and monitoring. So one thing we sucked at, and we really sucked, was the monitoring part. We had this internal solution called Sentinel. and it couldn't even tell you why things are not working, and it couldn't group it couldn't group alerts, you couldn't disable some part of metrics, etc., etc., and they lived with that for many years. Wow. What I did was I asked them, because I couldn't tell them, oh, you suck at monitoring, Sentinel is really so crap. I couldn't. The way was that I wanted them to feel that it doesn't work perfectly, I mean, far from ideal, and there are other solutions that works better. And I wanted them to start thinking about that. So I ran some meetings. I told them how monitoring works, like Isinga, Nagios, those old school ones, the newer ones like Prometheus, etc., and some SaaS solutions like Datadog or whatever. And they started thinking, wow, our Sentinel really sucks. What can we do about that? Because we don't have that much time to develop it. I asked them to choose one, and I helped them. We went with Datadog, which is a SaaS solution. And why we did that? Because we already had Hyperion besides Sentinel. Hyperion was other solution inside monitoring solution. As I told you before, we had a clusterfuck monitoring solutions, monitoring solutions. So I wanted them to group and to work on business side of monitoring, of metrics, of what we checked, etc., put it somewhere. So focus on what we monitor and how we monitor, and not on working on monitoring service itself. That's why I asked them to choose everything. So they chose Datadog, which is so expensive that my mind is blown every time. I mean, you can pay for one instance, for monitoring one instance 3 times more than for this instance itself. Yeah, not a reasonable price, but this is monitoring. This is very important. So I made them believe that this price is reasonable and that we have to go this way, because I wanted them to have order in monitoring and to really focus on their work and not on Sentinels, etc. And then when it was working fine, there was this team that was working on this Hyperion solution internal, and we started migrating to it, and now we sell it as something. Okay, and another thing, self-healing kit. How many time do we have? 5 minutes, okay. 5 minutes, and we are like, okay, I have to speed up. Like, really, self-healing kit. Okay, basically, when you have monitoring and you have automation, then you can work on self-healing. Your monitoring tells you something is not working, so monitoring triggers some automation job which tries to fix that thing. But as with automation comes this one problem. You have to build trust on things you automated. For instance, if you want to recreate whole Cassandra cluster, you have to really trust your monitoring and your automation tools, because if you try to recreate a database, stateful application in cloud, you can have huge problems. So first monitoring, then automation or the other side, and then run this manually for some time, so build trust, and you are there. OperationFlow. Basically, we put all procedures in one place, like documentation, wiki, or something. Then we work on this on RunTech. It's an application, open source application, when we can automate everything. It's like Jenkins part for operators. And also it's cloud agnostic, this nice word. And that's all. And we have it working in one place. Oh yeah, and we have this keep it simple, stupid in our company. No Kubernetes or no Docker, just plain VMs and ASGs, etc. We keep it this way because we don't have this team to operate Kubernetes. And as you know, Kubernetes, as cool as it is, it just needs someone to maintain this and all the environment. OperationFlow for Cassandra. Many procedures which are automated, clickable in RunTech. So we've got the UI, cluster restoration, adding new AZs, etc., etc. We all tested all of those, documented, and now it's working. If it's not automated, then it's documented at least. Yeah, it's how it works in RunTech. You can just run. And that's the funny. I mean, that's the thing we did in Cassandra maintenance workshops. We just put every possible scenario that came to my mind. What could happen? What could happen? Then we sort it by how important is that, And then we started working on this. Drills, yes and no. I mean, if you don't know how to recover your application and you do it manually, then drills are really needed, because instead of 5 minutes for recovery, you've got like 15 minutes for recovery, because people have to learn about the service itself during outage. However, not always drills are viable. So for instance, you can run workshops, and not always boring workshops. Let's say that you get one scenario from this, you roll dice, no one knows, and you exactly play an RPG game. So you are, during night, you are woken up, you get your phone. Hello, this is PagerDuty. Cassandra instance I number is down. Goodbye. What do you do? And then people just go around and tell you what do they do, and you as the dungeon master, you just hit some more problems to them, and you came to a solution or not. So it's a full plain work, no computers involved, and it tests if they know how it works and if they understand the solution they are working on. Instead of that, you can also play Wheel of Misfortune from Dustergon. Dustergon is a guy who actually created awesome SRE lists. I have URL on the last slide for that. Remember to review regularly your performance, your logs, your meetings, etc. Everything that is related to your reliability, things related to this application, the Cassandra. Every Monday we just go through charts and see if everything is cool. What it means that we are reliable enough right now? Guys don't have on-calls. From Cassandra, during the last 1 or more years, 12 up to 18 months, there were no at all phone call, no one phone call from PagerDuty about any problems with Cassandra after all those things. So I would say it's reliable. And also latencies are cool, meaning 2 milliseconds in 99th percentile, or like here. It's quite cool to write an information to database, yeah? 99th percentile. I mean, I know this Cassandra is fast, but still. Okay, and in no ops of word, I would say that whatever as a service is a way to go. Either you buy it, like RDS, or you work on this like our Cassandra as a service. But in order to work on this, you have to hire guys who know how to work on that. Yeah, the most important thing, developers have to understand deeply how the services work, like MongoDB, Kafka, etc., etc. If they don't understand, then you will have a problem someday. And summary. Yeah, you can read about that. Basically, introduce reliability to your developers and to your business and make them love each other, and that's all. URLs, Dustergon is the first one. And the empty slide, meaning it's over. Okay, thank you. If you have any questions, please shoot.
Hello, nice talk. Thanks for that. My question is how you do incident response. Like, do you have any tools for that? How do you, track what's going on? How many incidents, ongoing incidents are there? What's your process? Like, any suggestions on that side?
Okay, so there is like one people in every service. One guy in every service that is on call, and there is this second guy who takes the call when that one is not responded within like 10-15 minutes. And that's all. We don't have any incident managers, etc. People just take care. How we track what we did? We use Slack for that. We just have channels for that. And actually, we don't even have, we have channels for every service which is there, but we discuss this on 3 general channels. So if there are more involved people or services than this one, everyone knows that.